Hello everyone. This is my first lecture on engineering mechanics. So today in today's lecture we are going to see some of the fundamental laws which is very commonly used while solving the problems related to mechanics. So today the first type of law I'm going to discuss with you is the parallelogram law. You must have studied this law at the school level. So we just look at the law and how you are going to apply this particular law and what are the different applications related to parallelogram law will be discussed in this particular lecture. So let us look at a particular diagram here. In this particular diagram, we can see that there is a particular structure which experiences two kinds of forces, and one of such forces F1 and other forces at F2, and because of these two forces, the magnitude of F1 and F2 and also the direction of these two forces, the net force acting on at this particular point will be at a certain angle and also having certain magnitude or the amplitude, whose value that is normally indicated by R, and this R is also called the resultant vector. So we have two vectors F1 and F2, and the angle in between these two vectors is indicated by phi. So we are supposed to find out what will be the resultant force. This type of case occurs when a particular object which experiences two forces having two different directions, sometimes equal or maybe different magnitudes. Now, in order to look at or in order to find out the resultant value, what we are supposed to do in this case is we just want to move this particular F1, or we just want to fit this particular F1 exactly at the end of the first force. So if you do like that, then this angle is phi and this angle now is going to be phi, while the angle, which is this particular angle, is going to be 180 minus phi. And let us assume that this angle is alpha and this is beta. So this side is the resultant part, which is normally higher. In this particular cases, it is normally higher than the other two sides, F1 and F2. So one side is R, the applied force is F2, and another applied force is F1. The resultant is R. Alpha, beta, and 1 minus phi these are the different angles. Now, according to parallelogram law, the resultant force or the resultant vector R is obtained by the equation the first force square, which is F1 square, plus the second force square, which is F2 square, plus 2 times the first force multiplied by second force into the cosine of the angle between the two forces. So in our example, we have F1 and F2. The angle between, or the separation of the angle between F1 and F2 was phi. Therefore, the equation becomes resultant is equal to square root of F1 square plus F2 square plus 2 times F1 into F2 into cos phi. Now, the similar thing can also be solved using another particular equation, and this equation related the sides of the triangle with respect to the corresponding angles, and this particular law is called as the triangular law. So if you look at this particular case, that R is one of the side and the opposite angle, the angle just opposite of this particular side R is 180 minus phi. And if you look at the side F2, the angle opposite to the side is beta, whereas F1, the angle against that particular side is alpha. So this particular relation, that link between side and the sine of the what you call the angle facing that particular side. So the first equation is like R, the one of the side is R, divided by sine of 180 minus phi. That is equal to F1, which is this side, divided by the opposite angle, which is sine alpha. Similarly, F2, that is equal to F2 divided by sine beta. So r divided by sine of this particular angle, which is 180 minus phi, that is equal to f2 divided by the sine of the angle, which is sine beta, and that is equal to f1 divided by sine of the angle. There are some special cases. The first assumption, we are assuming that the angle between f1 and f2 are 0. So we are assuming that this angle is 0. So if it is going to be 0, then what will be the scenario? So let us look at this case when both the angle between these two vectors are 0. So what is going to happen when the angle is 0? Then it is going to be a, like they are in the same plane, or you can say this is a coplanar and having the same direction. So in this case we can see that f1 and f2, which are having the same direction, or there is no angle between. As a result, this part, because cos 0 will give you a value which is 1, as a result what you can find that this is going to be f1 square plus f2 square plus 2f1 into f2. So this is nothing but f1 plus f2 the whole square. As we have said, a plus b whole square is equal to a square plus 2ab plus b square. So what you can find that r will be f1 plus f2 the whole square, and because of this root we end up with an equation f1 plus f2. So this is going to happen when the angle between the two vectors are 0. Now the another case, when the angle between these two vectors is 90 degrees. So you can see that f1 and f2 exactly 90 degree displacement. So in this case we can find that cos 90 is nothing but it's 0. So what is going to happen is this part is going to be 0. So r is equal to square root of f1 square plus f2 square, plus this part is going to be 0 because cosine of 90, which will be 0. As a result, we'll get the equation square root of f1 square plus f2 square. And in case if you are interested to find out the angle of separation between the two vectors, I mean between the resultant vector and with respect to f2 of the side, we can apply the tan inverse rule. So tan inverse opposite side divided by adjacent side, that will give you the corresponding angle. So if you want to calculate the angle between r and f2 and assume that the resultant f1, I mean if you want to calculate the angle between these two vectors, what you can do is you can apply this rule, tan inverse the opposite side divided by adjacent side. Keep in mind that the angle will determine which side is opposite and which side is adjacent. Now the third case is if the angle between these two vectors is 180 degrees. 180 degree means that they are in the opposite direction. So as you can see in this particular picture, we can see that f1 and f2 are in the opposite direction. As a result, f1 square plus f2 square plus 2f1 cos 180, and cos 180 has got a negative value because its cos 180 is minus 1. As a result, we can find that f1 square plus f2 square minus 2f1. So this is the form of a minus b whole square, which is a square plus b square minus 2ab. And if you just get rid of this particular root, then we'll end up with f1 minus f2. It's also obvious that if a particular object is experiencing a force in the opposite direction, then definitely the net force will be the force which is having in the direction of the force which is having the higher amplitude, okay, or the force will be acting will be what, the difference of the two forces, and the direction will be moving, I mean the object will be moving towards the force which is having the higher amplitude. Okay, the same manner in this particular case, since the object is experiencing a force in both in the same direction, as a result the force will be added or force will be accumulated. Okay. So let us look at one example for this particular law. A cart is pulled uniformly along two cables using two hoses as shown in the figure. Now the tension forces of the two cables are given by 900 Newton and the other force, which is Q, 1100 Newton, and the angle between is already given. So in this particular case, there are two forces which are having magnitude. P is equal to 900 Newtons and Q is equal to 1100 Newton. And there is an angle of displacement between these two vectors, alpha is equal to 60 degree, and it is required to find out the resultant, what you call the vector. Okay, now as per the law, we know that first of all, we can convert the equation. So in this particular example, we have one force in this particular direction, another force in this particular direction, and this is having higher amplitude, this is having the low amplitude. This is the resultant force here. So we are supposed to find out how much will be the amplitude, as well as sometimes we are also require the direction, I mean the angle with respect to one of the vector, maybe either P or Q. So we can apply the law, and as per the law we can create like a diagram. As per the diagram, we know that P and Q are known, and the cosine is also known. So cosine is cosine 60, so 900 square, which is P square, Q square is which is 1100 square, and if you substitute, we'll find the value which is equal to 1734.9, which is equal to 1.73 kilonewton. So we can see that the direction, sorry, the magnitude of the resultant is 1.73 kilonewton. Okay, the same thing we can apply using the law of sines, or the law of angle law, or the triangular law. As per the law, we know that a particular side divided by sine of the what you call the phasing angle, and so on. So we can apply the same rule. So in this case, r divided by sine of this, then 1100 divided by sine of this, 900 divided by sine of the beta. So if you substitute that value, then what is required in order to solve it, because in our case we know the value of r, we know the value, we know the value of q, we know the value of phi, we know the value of p, then we will be able to find out the one of the unknowns. For example, if you are substituting this particular case, it is possible to find out the corresponding angle. So we already found the value of r from the above parallelogram law. We found 1734.9. okay, sine 180 minus phi, sine 180 minus alpha is 60 degree, which is the given degree. Then q is already known, then divide by sine phi. Okay, so let us assume that the phi is the angle which we are interested to find out, whereas the angle, given angle, we consider as an alpha. So if you refer back to the diagram, we'll find that this is 180 minus alpha, because as you know that this particular vector was acting at this particular point, so that's why we just displayed here. So once you display it, now this is going to be 180 minus alpha, and this alpha is already given, is like 60 degrees. So it is we want to know exactly what is the angle like beta and alpha. All other angles can be calculated. So this is 180 minus 60, which is going to be 120. So if you substitute that value here, so this is going to be 1734 divided by sine 120, that is equal to 1100 divided by sine phi. And what you can do is we can just cross multiply and find out the value of sine phi first. Sine phi we can calculate 1734.9 divided by 1100 times sine 120. So if you calculate that, we'll find the value of sine phi. And if you want to calculate the value of phi, it is nothing but sine inverse. So if you have to shift, and if you use calculators, use shift and sine, you will find out this sine inverse, and we'll get the value 33.3 degrees. So we can find that one of the angle is 33.3. Same way, we will also can find out the value of beta by substituting for the other parameters, which is having sine beta term. So if you do the same process like the cross multiplication, and you will be able to find out the beta angle, which is 26.7. Now normally when we add these figures 26.7 and 33 and the given angle, which is 180 minus 5, which is 120, so we're supposed to get totally 180 degrees. So that is how to check whether the calculation is correct or not. So this is another example. This example is like a steel pulley that is used in luggage transfer from ground level to other roofs. You will find something construction sites and other airports and so on. If a box that weight 0.5 kilonewton is being lifted by a worker that weight 0.7 kilonewton using the fabric rope and pulley. Now the question is here, we have to find out, determine the force that which the man's feet transfer to the ground. So this is something like a reactive force or reaction force. So this is the weight, and this weight has to be it is equivalent to 0.7 kilonewton experienced on a person who tried to. So this force is, this question is like a reactive force, because we want to calculate the force that exert man's feet, and or the amount of the force that is the man's feet transfer to the ground. So this is it's a reverse process, or you can say that this is something but the force which is acting in the opposite direction, because this that's why we call as a reactive force, because we are applying a force on the ground. Then definitely the ground has got a reactive force that is normally in the opposite direction. So if you look at this one here, you can see that the angle which these two forces are acting exactly opposite, and hence the angle is going to be 180. And if you apply the rule a square plus b square, or p square plus q square into 2pq cos the angle between, we'll find that this angle is 180 degrees. So we have the equation w square plus f square. I think there's a mistake here. F square minus 2 times wf. So w square plus f square minus 2 times wf. So if you calculate that, it is going to be w minus f. Or you can say that since these two forces are in the opposite direction, we can simply calculate the differences, which is 0.7 minus 0.5, which means 0.2 kilonewton, and normally it is applying in the downward direction, because the more force will be from the top. You have 0.7 k, whereas the actual weight is like what, 0.5. so because this is the 0.5 and here is 0.7, so you have a net force of 0.2 kilonewton, which will be acting downwards. So this is the basic examples. Okay, so in this lecture we have just introduced two particular law which are very common in engineering mechanics. These laws are the parallelogram law and the triangle law, or the law of sines. So as per the parallelogram law, if there are two forces A and B which are acting on an object having the angle of differences, the angle between these two forces is let us say theta, then the resultant force is calculated by the equation p square plus q or a square plus b square plus 2ab cos theta. Okay, and if you are interested to find out the angle, normally the parallelogram law, once you apply, the angle will be exactly half. Then another important thing is, in order to calculate the angle, different angles, we can apply the law of sines. As per the law of sines, if a, b, c, capital A, B, C are the sides and small a, B, C are the angles, then a divided by capital A divided by sine small a is equal to capital B divided by sine small b is equal to capital C divided by sine small c. So this is the law. So if you know three parameters, by equating two of these terms, first two term, last two term, or the middle term, we will be able to find out the unknown value. And it's also very common to find the angle. So in these cases, the first thing is we apply the parallelogram law followed by the law of sines. Thank you for watching.